Okay, good morning, seventh graders of JCA. I have hopefully a helpful lesson to do for you today that will give you a basic crash course, if you will, on graphing on the Cartesian plane. All right, and you're going to need these preliminary lessons that I'm going to do with you. You're going to need this for your ones that you will start on the ABECA website, streaming website there, starting at lesson 120. I'm just going to give you the introduction from a distance here to the Cartesian plane, how to graph. So let's get started. It can be fun. You know, you gotta look at it as a good thing, fun thing, and really just have fun with it. Sometimes I look at the Cartesian plane kind of like a battleship game, if you want to look at it that way. That's what I did with the 8th graders this year. We did Battleship in class because remember in Battleship you're trying to, you got your ships placed in a certain spot, and then the other team, the other person playing against you has to guess where your battleships are, right? And they guess with of course a letter and a number, but with the Cartesian plane it's a number and then another number that matches up. So if I was gonna put my battleship at 3, 2, I would say, well, I count over to the right 3 spaces and up 2, and there's where my battleship would be, right there. And you can't see as well as I'd like there on the video, but there are lines here. This is a graph paper, and of course you'd be using graph paper in your lessons and your assignments, where you could actually find out where that point meets. That point of 3, 2 would meet right here, where the line at 3 right here and the line at 2 right here meet. Okay, so we got 1, 2, 3, and then we got to the right, and then up we got 1, 2, and where those two lines meet right there would be your point at which 3, 2 would be the address, if you will, to that point. Now you could look at it as an address, kind of like we would on a city map. I have the map of Chicago here. The center of the universe there, Wrigley Field, Clark and Addison Street. Being a Cubs fan, I kind of enjoy looking at that. What we have here is where 2 streets meet is the point at the corner of those streets, right? And it kind of looks like a Cartesian plane because it has streets going east and west, and it has streets going north and south, right? So it's kind of like that. If I started there at the center of the universe, Wrigley Field, and then I would go over 1 block to the right, that would be 1. And then if I went, let's say, so that would be east, that's to the right, that's positive. If I went down, that'd be negative. To the south, that'd be negative. And so if I went down, let's say 3 blocks, I would go 1 and then down 3. I'd be at this point down here. You see, it's just kind of an illustration of how we're looking at the Cartesian plane here, this graph. Okay, so just some basics of it, all right, to help you with it. Your book there on page 344, you have some reading. You need to make sure you read through this and try to do your best to understand. And please call me if you have questions, text me, whatever. But you notice on the graph there, the Cartesian plane is what it's called. The first reference point, the origin, kind of like where we started on the map there at Wrigley Field there. The origin point, the starting point, is always called 0, 0 because it's not up, not down, not right, not left. So there's no negative or positive there. It's all 0, right? So 0, 0 is the origin point right here. All right? I'll go ahead and erase that point we had over there. So if I was going to go to the right, I would be going positive, okay? If I was going to the left from the origin, I would be going negative. See, all these numbers, and you can't see very well in the video, but all these numbers are negative. To the left, okay? All the numbers to the right of 0 are positive. And then the same thing for up and down. You have a number line going vertical also. So what you have here, going down is negative, going up is positive, all right? Now, it's important to know that the horizontal or the left-right axis is called the x-axis, all right? The vertical, the up-down axis is called the y-axis, all right? Okay, and as you move one direction or another based on the sign of the number, you'll know where to go and put your point on. All right. So if I was gonna like I did before with the example earlier, if I was gonna say, let's say I was supposed to find point 4 comma negative 1. All right. 4 comma negative 1. What I would do is I'd see, okay, the first number is 4. That's x. Now it makes sense that x is first because it comes before y in the alphabet. So just remember that x comes before y. So it's always going to be in that order, x comma y. And this is called an ordered pair, okay? And in your ordered pair, it's going to tell you where to go on the graph and put your point or your dot, if you will, all right? So I look at the x, and the x is 4, all right? Since the x is 4, I'm going to go to the right 4 spaces. Now I'm not going to go negative because it doesn't have a negative sign, it's a positive. So I go to the right. I go over to the 4, and then I'm not done. I have to look at my y to see where to go up or down, okay? And since it's a negative 1, I'm going to go down. Down only one spot, and here's my point. That is called 4 comma negative 1. That's the ordered pair for that point right there. And just like on a map, remember our map, just like a map where you can actually find the intersection of streets based on just, you'd say, the corner of Grant and Ohio, or the corner of Ontario and Superior, or whatever the street name is. It's the same way on a Cartesian plane. You have a corner of a street, of 2 streets meeting. And those names, though, are numbers. They're not, obviously, names like, you know, whatever street you live on. Let's say you live on Talladega Street. Well, it's not like that. It's like a number, okay? So each point, like this point right here, has a street address, if you will, of a corner where the streets meet, and it's 4 negative 1, all right? Let's find another one. We could do another example. What we'll do is one in the book there. Let's go over to page 346. If you go to 346, practice 9.1, it says, the directions say, write the ordered pair of each point. Well, let's say it says point A there, okay? Let's put point A where it is there. I'll put it over there, okay? Here's where point A is on your paper there, as you can see. Point A is there. And we're going to say what the coordinates are. And how do we find out what the coordinates of that point is? Well, we always start at the origin. Origin means starting point. So we start at 0, 0 here, and we're going to go, well, we always go left or right first because that's the x-axis is always left or right. We don't go up and down first, we go left and right first. So we go to the right and go 1, 2, 3, 4 to get in line with our A. See there, our point A? It lines up with 4 on the x-axis. And so we go there, and then we're going to find out how many it takes to get up to that point, exactly to that point. So we go 1, 2. And of course, that's our number then. 4 comma 2 would be the address for point A, or the ordered pair for point A. All right, so that's number 1 there. Let's skip down to number 7. Number 7 says point O. It says plot each point on the Cartesian plane and label it with a given letter. So we'll go and find the, we're given the address here, or the ordered pair, in order to plot that point on the graph. So we'll do that. Point O says -4, -5. So we'll do that. Go up to -4, it says first, so we'll go to the left 4, because left is negative. And then it says -5, that's down. 1, 2, 3, 4, 5. And there is point O. That's where you should have point O. Please do that with me, students watching. Do that with me on your graph on page 346, so that you can see that's how you get to point O. Is by using the ordered pair that's given. You can actually put it on the graph and label it with the point that it says there, point O. Okay, we can do another example here. On page 347, it shows you on the blank grid, draw the Cartesian plane and label the axes, origin, and quadrants. Now, that's why I wanted to talk about this too. I want to talk about quadrants. And on the previous page there, page 344, it told you what a quadrant is, but I'll just explain it real quick. Quadrants are basically, you know how you got your x and y axis here dividing up this whole Cartesian plane here. And what you have is you have it split up into quadrants, 1, 2, 3, and 4, okay? So this is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4, okay? So if you want to know what quadrant a point is in, well, you just look at, well, where's this point at? Well, it's in quadrant 3 right here. It's labeled quadrant 3. And I've done that so that you can understand how to know the quadrant, all right? It's the easy way to remember it is you start at 1 with all the positives. If the x and the y are both positive, it's going to be right up here. Going to the right and up is going to be in this quadrant right here. And that's quadrant number 1. And then you just go from there counting counterclockwise. You count counterclockwise. 1, 2, 3, 4, like that. And so that's the easy way to remember how to get the quadrants correct. 1, 2, 3, and 4, counterclockwise, the opposite way that a clock goes. All right, so we're going to do number 13. Let's do number 13 real quick together. It says that we're supposed to put the quadrant of the point -2, comma -5. So let's go there. First of all, we're going to do -2. Well, that's the first number, and it's the first letter is always the x. The x-axis is left and right. So where are we going to go, left or right? Okay, if you said to the left, you were correct, because left means negative, and -2 is our first number, so that's why we go left. All right, so we go -2, but we're not done. We have to finish with that y. That y says -5, so we go down 1, 2, 3, 4, 5. There's our point. And what quadrant are we in? Of course, we're in quadrant 3 again. All right, so number 13 would be quadrant 3. We would put that in the blank right there. Then number 14 says we're going to 6, comma 1. Well, again, the x is first, and it's the 6. And so we're in left and right. We're deciding on to make sure that we are going the right direction. Well, which way are we going? If it's a number 6, it's positive 6, right? Positive means go to the right. So we're going to go over 6 right here. And then it says 1, right? That's our y. So we go up 1 because we're not going down because it's not negative. It's positive. So that would be our point. And what quadrant is it in? If you said quadrant 1, you are correct. Quadrant 1, of course, is where you're at. See that? All right. And so you would put in the blank quadrant 1, right? That would be your answer for number 14. So hopefully that helps you understand a little bit about the quadrants. We'll stop there for today. I want you to go ahead and do all the practice problems 1 through 20. All right, for today. 1 through 20 on page 346, 347. Okay, and then you can also do some more practice. It would be problems 1 through 14 on the homework section. That would be page 351. So page 351, the homework section, number 1 through 14. And then again, practice problems on page 346, 347, go 1 through 20. And please call me, text me if you have questions. I am here to help you all day, the regular school day as normal. So please do that. If I don't have your personal cell phone number, please text that to me through your parents. Find that out from your parents, that's fine. If the parents need to be the ones that I contact, that's fine too. We can go through you, but I'm trying to make sure that as little of the responsibility as possible is on the parents. I just want to try to help the students as much as possible as normal, okay? But if you have questions, please let me know. All right. Hopefully this was helpful to you, and I'll make another video later.